In this video, we're going to discuss what branches, nodes, and loops are. These are pretty important concepts that you have to really internalize them so that when you're analyzing a much more complicated circuit, you just instinctively know what each of these things are going to be going on. Otherwise, you won't know how to analyze the circuit properly. So first off, what is a branch? A branch is a single circuit element. And so a branch might be a resistor, it might be a source, voltage, or current, it could be a capacitor, it could be an inductor, and so on. These are all the things that are going to be branches in our circuits here. A node is a connection between two or more branches. On our picture down here really quickly, this right here would be a node. It connects three resistors, so it connects three branches. And lastly, a loop is a series of branches where each successive branch is connected to the previous branch by a node, and we specifically care about closed loops, and the final branch is the same as the initial branch. So if I take a look down here on this circuit here, let's see if I identify all of the different components here. So I'll go ahead and use red here. So this right here, that is a branch. This right here is a branch. This, and this. And so you see I have 1, 2, 3, 4, 5, 6, 7. There are going to be 7 branches here. Now I totally understand that you might say, well, wait a second, this source and this resistor over here, I could just call that one branch, right? They're all connected. That looks like it's one connection branch there. And let me hold off and answer that question in a minute or so. So we've got our branches here. Let's look at our nodes. So we've got a node that we already said here. This is a node. We've got another node between these two elements. I got a node between these three here, a node here, and then all these here are connected together on the bottom. That's also a node. So we have 1, 2, 3, 4, 5 nodes. Now here's the thing about loops. If I were to go ahead and say this right here, I travel around through different branches, each one connected by the nodes, and I arrive back at my starting point. That's a perfectly good loop. However, we could have also done a loop that looks like this, or we could do other loops. We could even get really interesting and say, let's go here, and then here, and then back. And you can have these weird circular loops here. So really, especially if you think about going around more than once, you can have infinitely many loops. But we're going to be using these to set up systems of linear equations. And if you're doing that, you need your equations to be linearly independent in order to solve for them nicely. So we don't care about just any loops, we want independent loops. So we want to know how many of these are going to be mathematically linearly independent so that we can solve equations based on them. And that might not be that obvious, because who knows exactly how many loops you need to make up this whole thing here. I will go ahead and tell you right now, it's going to be 3. And again, just like if you think about linear algebra class, you don't necessarily have to have the same 3 elements as your basis. You can have different sets of 3. On the other hand, not every 3 loops would form a basis here. So let me show you 3 quick examples that would work nicely. So I could use this one right here as like a loop 1, this one right here as a loop 2, and this one as a loop 3. And if I use those would be independent and it'd be fine. Now again, it's not the only choice of 3, but it's going to be probably our most convenient choice of 3 loops. Now if we notice these 3 numbers here, it turns out they're going to satisfy an equation. They satisfy an equation here as follows here. The number of branches is equal to the number of nodes plus the number of independent loops minus 1. You might say, well, okay, sure, these specific numbers work, but it turns out this is true, that the number of branches is equal to the number of nodes plus the number of independent loops minus 1. Or if you want to, you can solve for the independent loops to find out how many they're going to be. That would be b minus n plus 1. And this has a name here. This is called the fundamental theorem of network topology. Fundamental theorem of network technology. So topology, not technology. So the topology is a branch of mathematics where you try to study how things can change or not change based on what are called deformations. So for example, if you took a shape here, your typical triangle, and you started curving things, it's no longer a triangle, but it does still have 3 specific points here. So if you've taken a class on graph theory, this is the basic idea of graph theory. You only care about the connections between things. You don't care if it's straight or curved or whatnot. All you care about is how things are connected. Now with all of this here, there's a little side topic, which let's go ahead and use this one for, and that is going to be a mesh loop, which are the ones we're usually going to use here. This is going to be a loop with no subloop inside of it. So if you saw my 3 loops here, loop 1, loop 2, loop 3, there is nothing inside that loop that would also be a loop. And so that's what those are examples of mesh loops there. And if you always pick mesh loops, you're guaranteed to have independent equations. And so as you'll see as we go into further and further examples, we're kind of just by default going to be picking our mesh loops, these things on the inside of them. Okay, so this is our rundown of what branches, nodes, and loops are.